So here's an example of kind of a generic block diagram of a generic manufacturing system. So typically in manufacturing, you've got maybe some robotic motion control, you've got some conveyors, you got parts being made, and the different technologies involved. There's 3 different types of motors that you're going to find, the most common types. Stepper motors, which are designed to move in discrete steps. Brushless motors, which are kind of like, they have 3 coils, 3 phases, and they're designed for rotational motion in either direction at any speed. And then a regular brushed DC motor. The DC motor is the simplest one to control. You just have 2 wires. You run current one direction, it rotates one way. You run current the other direction, it rotates the other way. And so the rest of these, and so you see down here, this is an H bridge, and this is kind of like an H bridge that's been modified, or another half bridge has been added to control the 3rd phase. And then the stepper motor actually uses 2 full H bridges, 1 for each coil. So those are some of the motors that you'll find. And so every one of those motors has different drivers, motor drivers. Then on the other side, you've got sensors. You've got position sensors and proximity sensors. They don't show them here, but there would also be optical encoders sensing the speed and position of the motors. And all these, this diagram actually came from, I'll just go on the web for a moment here. It came from Allegro Microsystems, which is an electronics company that makes the electronics for a lot of these automated systems. And so these are all links. So if you, let's say you wanted to see what types of brushless motor controllers they had, if you click this, it brings up a little diagram, and there's 4 different families of parts. So if I click on this one, A4939, there it is. That's the actual chip that's used to control the brushless motor. And if we click on this, it brings up the data sheet. So all the information. So if you were an engineer designing this system, this is where you would go to find out what kind of electronics, what kind of power supply is required, what the performance data is. So that's all part of mechatronic systems. It's the electronics that's behind it. So then all these other links will also lead you to different electronics. Okay, so one thing's, when we're looking at any one of these systems, there's something that is a useful way to analyze and look at a system, especially when you're doing troubleshooting on the system. And that is how the energy is flowing through the system and how the information is flowing through the system. Where does it start and where does it end up, and what are the different points in between? Usually troubleshooting, you're dealing with a problem because energy is not getting where it needs to get to, or information is not getting to where it needs to get to. So learning how to break that down and trace that is an important skill. So let me give you an example, or just not an example, an overview. So when we talk about flow of energy, the first thing is to know which components are using energy, and so you're going to look at your moving parts, or anything that produces light or heat, LEDs, indicators, displays producing light, heating elements producing, heat. And then the next thing is, what type of energy are these things using? Is it electrical energy? Is it pneumatic energy? That's compressed air. Hydraulic, compressed fluid. And where is that energy coming from? So it could be, you want to know the primary source. Like in terms of electrical energy, somewhere there's an electrical panel that's the ultimate source of the electrical energy. Well, actually, if you go further back, the ultimate source is some generator somewhere, or maybe a solar plant or something. But from the purposes of your equipment, your energy, electrical energy is coming from the electrical panel, gets to your system somehow, and it goes through various switches. There may be an emergency shutoff and a main power switch, and eventually it gets to the power supply and powers up the system. So that'll be the source. Or the pneumatic, there's going to be a compressor someplace providing compressed air, and then the compressed air is delivered through multiple ducts and pipes to the system. So the last part of this is identifying what delivers the energy to the actuator. How does it get there? So there may be a relay involved, maybe a transistor, or maybe more than one. Maybe some kind of a power IC. Really, a power IC is just an IC that has multiple transistors on it. So that's pretty much the same thing. Okay, so that's really when you're troubleshooting. You want to, and that's a lot of what you're going to be doing in the course, is looking at the electrical diagram and identifying where the energy comes from, how it gets to where it's going, and what kind of components are controlling it. So we talk about flow of information. We're going to look at what components are there on the system that process the information. So an example would be a PLC or an embedded controller, a microcontroller. So that's where the information is being processed. That means the information is flowing into it and out of it. Or it could be a computer-based system. What type of information is being processed? So is it digital? Most of the time nowadays it's digital. But in some cases it may be analog. There may be some analog sensor going back to the PLC. So are we talking about just ones and zeros or pulses? Or are we talking about, say, a range of voltages between 0 and 10 volts that are being sent? And then what's the source of the information? Are we looking at an output, a digital output from the controller to switch on a relay output, for example? Or we're looking at some sensor that's putting information back into the controller. And then what kind of logic is used to process the information? Is it software? Most of the time in a modern system, it's going to be software. There are some older systems that are hardwired to only perform one process, which are, but that's not very common nowadays. But in some cases that is the case. All right, so that's just another way of looking at a system. And so as we go through the course and look at various systems, we're going to be analyzing it in this way. We're going to be looking at how does energy flow through the system? Why is that actuator not moving? And where's the path of energy to that, and what's interrupting that? Or is it a matter of information? Maybe all the energy and the relays, everything's in place, but it's just not getting the information from the controller. So that's another part of troubleshooting. Okay, so I hope you enjoyed this presentation. Good luck in the course, and we'll move on to bigger and better things. Okay, bye.